Hello, this is Miss Moore, and today during chemistry we're going to discuss types of chemical reactions. This is really a review lecture as we're wrapping up the unit, but before you embark on trying practice problems of mixed reaction types, I wanted to do a quick overview. So today's essential question: what are the 5 types of chemical reactions, and how do you predict the products of each? You might want your periodic tables handy. And here we go. So, as mentioned in the essential question, we have talked about 5, well, that's not a good size. Let's try that again. How about this one? We've talked about 5 types of chemical reactions. So they are, first, the combustion reactions. And then we have, what do we talk about next? Synthesis reactions. And then we have decomposition reactions. And then the 2 replacements or displacement reactions. We've got double replacement also known as displacement. And we have, last but not least, our single replacement or displacement. Okay, and so there's the list of the reactions you should know, be able to recognize, and be able to predict products of. What we're going to do now is just quickly go over each one of them. Make sure you've got this straight. And we will start with combustion reactions. Okay, so a combustion reaction, the reactants for us, okay, there are other combustion reactions, but for us, our reactants will always be a hydrocarbon plus oxygen. Okay, so a hydrocarbon is something made up of just C's and H's, or C's, H's, and O's. And the products are always going to be carbon dioxide and water. So the cool thing is for these, you don't really have to predict the products. They're always the same, carbon dioxide and water. So now let's write a general equation. So the general equation for a combustion reaction with a hydrocarbon, which is the only combustion reaction we're going to be talking about, would be C something, X meaning some number, H something, O something, or it could be just C something, H something, plus oxygen, which remember is O2 because oxygen is a diatomic, producing the 2 products, carbon dioxide and water. Okay. So when you're completing combustion reactions, you need to first predict products. which is really easy because the products are this: carbon dioxide and water. And then the second thing you need to do is balance. Now, when you're balancing these, remember that these are awful. How do you spell awful? I don't think that's right. Okay, I'm a horrible speller. We're going to go with awful. Are awful to balance. Okay, but predicting the products is easy. Yay, easy. Carbon dioxide and water. Balancing, these are awful to balance. All right, on to our second reaction type, which was synthesis reactions. So for a synthesis reaction, let's see, the reactants are going to be two things, just two things. Okay, and our products is going to be one thing or one compound made up of the two reactants. For us, by the way, these will usually be just single atoms. Usually. All right. Let's see. Next is the general equation. So our general equation for a synthesis reaction is A plus B, so two single things, producing the product AB. So these two single things as reactants get squished together to make this new thing, AB. All right, so what do I want to tell you about this one? Okay, so for completing a general, or for predicting products, so for completing a synthesis reaction, what do? So first you predict products. So you predict the products, meaning you, how do I say it? You put the two reactants together. Okay, but don't bring subscripts to product side. Okay, step 2, if product is ionic, which means a metal and a nonmetal, you need to check charges and neutralize. And then, and then the last step is to balance. So now let's do a quick example of a synthesis reaction. So for example, let's take H2 plus O2. We know this is synthesis because our products, we have just two single things there. So remember, in a synthesis reaction, let's scroll up for a minute, what we do is we put the two reactants together. Don't bring subscripts to the product side. So what we're going to bring over is the H and the O, and we're going to squish them together into one thing. So H, O. And you will note I did not bring the subscripts with me. If the product, step 2, is ionic, a metal and nonmetal, check the charges and neutralize. So we have H, which is not exactly a metal, but he's on the metal side, so we're going to treat him as a metal. And we have O, which is a nonmetal. So we have to check the charges. So H has a 1 plus charge, O has a 2 minus charge. So to make those neutral, we need to add another H, which makes it H2O. Okay, so now the last step is to balance. So we make the list of atoms. We have H and O. We have 2 H's and 2 O's on the reactant side and 2 H's and 1 O on the product side. So at the moment our H's look good. We need to fix our O's because we have 1 on the reactant side and 2 on the reactant side, 1 on the product side. So I'm going to put a 2 here, which now gives us 4 H's because that 2 distributes to both atoms. And we have 2 O's. So we've fixed the O's. We've now messed up the H's, but all I need to do is put a 2 here. We now have 4 H's. Okay, so there's a quick overview of. And next up is decomposition. All right. So for decomposition, our reactants is going to be a single compound. And our products, the compound breaks up into two things. For us, for now, those 2 things are going to be 2 atoms. Okay, they're just going to totally break apart. Okay, so then our general equation will be our compound AB, which breaks apart into A plus B. So you can see it's the exact opposite of synthesis reactions. All right, so what do you need to do to complete the reaction or to predict products? So to complete the reaction, you really just separate the single compound into single atoms. You need to, what else do you need to do? You need to check for diatomics. You need to check for diatomics. That's an important one because you're writing single atoms, right? So we definitely need to check for diatomics. And remember diatomics, you can remember HN7 or Hoff-Brinkel. So basically the diatomics are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Okay, and you definitely need to know that. And when you're done with that, the last step is your favorite, to balance. All right, and let's try a practice problem. And let's just use the opposite. So let's say I had water. And we're going to break this apart. Oops, I forgot to tell you something up here. Go back up to number 1, separate into single atoms. Don't bring subscripts. Don't bring subscripts over. Okay? All right, so back to this. There's our practice problem, H2O. So what we do first is separate into single atoms. Do not bring subscripts with us. So we're going to just have H and O. And we're going to separate those. So we're going to have H plus O. Okay. Then step 2 says check for diatomics. H is a diatomic, so we need to make that an H2. And O is also a diatomic, so we need to make that O2. Last step is to balance. So we're going to write our list of atoms, HO. And on the reactant side, we have 2 H's and 1 O. And on the product side, we have 2 H's and 2 O's. So changing colors, our H's look good. We need to fix those O's because we only have 1 on the reactant side and we have 2 on the product side. So I'm going to put a 2 here, which unfortunately messes up both our H's, but fixes our O's. So now we need to fix our H's. And there you go. There's a completed decomposition problem. All right. On to single replacement or displacement reactions. All right. So for a single replacement reaction, the reactants is going to be a single atom and an ionic compound. Products will be also a single atom and an ionic compound. Okay, and the general equation will be, I should have done double replacement first. Oh well. The general equation will be A for our single atom plus XB, our compound, producing X plus AB. So what happened here is that the A and the X switch places. All right, so to complete a single replacement reaction, forgot the N. So to complete a single replacement reaction, first assign charges. And then we have to use the activity series, how do I say that? We're going to use, I guess we'll say that. We'll use activity series. You're going to, the atoms in the reactants with same charge are going to fight. And the winner is higher on activity series. And the winner gets to hook up or bond with atom with opposite charge. Okay. Then we need to, for single atom, you need to check for diatomics. And for our new ionic compound, you need to check charges and neutralize. Okay. And of course, the last step, everybody's favorite step, is to balance. Okay, this one had a lot of steps in it, but hopefully it'll be a little bit more clear when we do a practice problem. All right, so let's do a practice problem. And our practice problem, let's see, let's pick barium as a single atom plus NaCl. Okay, so first of all, we know this is going to be a single replacement atom because we're starting out, or a single replacement reaction, because we're starting out with a single atom and an ionic compound. So our first job is to assign charges. So barium has a 2+ charge, sodium a 1+ charge, and chlorine has a 1- charge. All right, so who's going to be fighting it out? Well, barium is going to fight it out with sodium because they both have positive charges. Okay, so let's look on our solubility rules. We're looking to see who's going to win this fight. And remember, it's the one that's higher up on the solubility rules, on the activity series. So we have barium here and sodium here. Barium's higher up, so he's the one that's going to win the fight, and the winner, that's right here, the winner is higher up on the activity series, and the winner gets to hook up or bond with the atom of opposite charge. Okay, so barium's higher up, so he gets to hook up with chlorine. I'm going to erase a little bit here so it's a little less confusing. Let's get rid of these circles now. So barium won the fight, which means barium gets to hook up with chlorine, which means sodium is left all by himself. So on the product side, sodium's alone, and barium is now going to hook up with chlorine. So there are products. So now, looking at step 3 here, we need to check for diatomics for our single atom. Sodium is not a diatomic, so he's good. Step 4, ionic compounds, we need to check charges and neutralize. Well, barium chloride is indeed an ionic compound because it's a metal and a nonmetal. And we already know barium has a 2+ charge, chlorine has a 1- charge. So we need one more chlorine to make this compound neutral. So we got that. And the last step is to balance. I'm going to get rid of all these charges now. And to balance, we make our list of atoms. And whoops. Now we make a count. We have 1 barium, 1 sodium, 1 chlorine on the reactant side. And on the product side, We have 1 barium and sodium and 2 chlorines. All right, so on to balance. Barium looks good, sodium looks good, chlorine not so much. We have 2 on the product side, 1 on the reactant side. So if I put a 2 right here, that'll fix our chlorines. Unfortunately, it also messes up our sodiums. So we now have 2 sodiums on the reactant side and 1 on the product side. So to fix that, we could stick a 2 right here. And there you go. We're done with single replacement reactions. All right, on to our last reaction type, which is double replacement reactions. All right, so for double replacement reactions, the reactants are going to be 2 ionic compounds. Our products are also going to be 2 ionic compounds. The general equation is going to be AX plus BY produces BX plus AY. All right, so hopefully you'll note as you write that down that what happened was the A and the B swapped places. All right, so now how do you complete? How do you complete the reaction? So the first thing you do is that the metals, or the cations, swap places. So, you know, that should probably be our second step. Our first step should be that we're gonna check charges, so we know what our metals or cations are, right? So the metals or cations swap places. Do not bring subscripts to product side. And you'll note that that's true of all the reaction. Okay, so then we need to, for the products, we need to check charges and neutralize. Okay, and then last step is to balance. So let's try a practice problem. So let's try, how about NaCl plus, what do you think I should use? CaCO3. All right. We know this is a double replacement reaction because we have 2 ionic compounds. So our first step is to figure out the charges on each of the atoms or ions in the compound. So sodium is a 1 plus, chlorine is a 1 minus, calcium is a 2 plus, and carbonate is a polyatomic, and it has a charge of a 2 minus. All right, so what's going to happen here? Well, the sodium and the calcium are going to swap places. So what we'll end up with is calcium 2 plus hooking up with chlorine 1 minus, and sodium 1 plus is going to hook up with carbonate 2 minus. So I want to talk really quickly about, I said do not bring subscripts to the product side. However, even though that's a subscript, we're talking about carbonate is all one thing. You need that subscript because carbonate is CO3. All right, so next we need to, for the step 3, we need to check charges and neutralize. We're good on the reactant side. Those were already neutral, so we're good with that. Product side, CaCl, calcium has a 2 plus charge, chlorine has a 1 minus charge. So we need to turn that into CaCl2 to make that neutral. And for sodium, we have a 1 plus charge. Carbonate is a 2 minus charge. So that makes that compound neutral. So last step is to balance. We have Na, Cl, Ca, CO3. And we can keep the CO3 together because we have a CO3 on both sides. Okay, so we have 1 on the reactant sides, 1 sodium, 1 chlorine, 1 calcium, 1 carbonate. Product side, 1 sodium, 2 chlorines. No. Try that again. Hope you were shouting out at me. We have 2 sodiums, 2 chlorines, 1 calcium, 1 carbonate. So sodiums, we need to fix the sodiums. So if you put a 2 on the reactant side in front of NaCl, we end up with 2 Nas, 2 Cls, and that's it. We're done. Okay, so guys, this was just an overview of all the types of reactions. If you're struggling with any of these, please check School Loop, Google Classroom, or if you would prefer, go to my YouTube channel, More Chemistry, and find full lectures about any of those. All right, that's it for today. Have a good one.